Okay, are we ready, everybody, to get started? I had not intended on handing that out to the end of class, but because of the delay, kind of had to. So let's go ahead and just click in that you're here. Is that everybody? Okay. Okay, I would ask at this point, everyone, that the review thing that I gave you as group stuff, let's just put that aside for now, okay? I don't want you all working in groups right now. So here's the idea for Wednesday, all right? Make sure that your group has done all the problems. Everyone has 3 problems, except for group 1 has 4, yes? Okay. Each group turns in 1 answer sheet, so however you want to do that. If you do them separately and put them together and, staple them, that's fine. If it's different handwriting, it doesn't have to be the same thing. I just don't want to have, like, everyone in the group's work, everyone did all 3 problems. I want it in order, the 3 problems or 4 problems you had to do. Put your group number or group names on the top of what you turn in. Each group member be prepared to explain at least one of the problems. That means most likely what I'm going to do is I'm going to say, okay, group E, you had to do number 15. I'd like for 2 of your group members to get up and show us how you did 15. That's what I want you to be able to do on Wednesday. All right? What's that? I don't know how we'll do it yet. Okay? So basically, you need to be prepared to come in here and defend one of the problems. Each one of you needs to be able to defend one of them. So if you want to group up, like this group has 6 people, you only have 3 problems. If you want to pair up on problems, that's fine. Does this all make sense? Okay, so we'll spend a lot of next class talking about these problems, which I think will be a good preparation for the exam. All right. What's that? Well, anything that's you've seen is fair game on the test. So, all right, so we are going to continue where we were last time. We had started talking about partial fractions, and specifically, we had done 2 examples. We had seen that whenever we have a polynomial divided by polynomial, we like to try and first look at the degrees of the polynomials. Then we come in with synthetic division or long division if we need it. And then we try and break up the denominator. So if you look back in your notes, we did the first 2 problems right here. And so I'm going to pick up right here, and we're going to do C, D, and E now. Let's see how long that takes us. I think we'll finish before time is up, and then you can continue working in your groups. Okay? So let's do E. C. So we want to integrate x to the 4th minus 2x squared plus 4x plus 1 over x cubed minus x squared minus x plus 1. So we first recognize that this is a polynomial divided by a polynomial, so it's a rational function. We compare the degree of the numerator to the degree of the denominator. we have a 4 on top and a 3 on bottom. So whenever the degree of the numerator is bigger than or equal to denominator, we first start with long division, right? Okay, so I'm going to set up a long division first. Inside goes my x to the 4th. Then what? Plus 0x cubed. You need to account for the gap that you have there. You do not have an x cubed term, so we usually put a 0 there just for spacing issues. And then on the outside, we come in with the divisor. And then we ask ourselves, what do we need to multiply x cubed by to turn it into an x to the 4th? So we just need an x. I've seen some people just put x up here anywhere. I've seen other people where they actually line the x up over the x here. It's really up to you. I'm just going to put an x up here. And then what we do is we take that x and we multiply it to the divisor. So x times x cubed gives us x to the 4th. X times negative x squared gives us negative x cubed. X times negative x gives us negative x squared. And finally, x times 1 gives us positive x. We come through with this line, and we subtract it, which changes all the signs. You do what you want. Remember that long division is not a technique that we're learning in here, right? This is something we've seen, hopefully. So if you've got a way that you like doing it, you don't have to follow mine. Just make sure your way is getting you the correct answer, all right? So minus x squared, and then plus 3x. Everyone agree? Okay, so now we do the same thing. We try and make our x cubed up front an x cubed. So we multiply by 1. So we say plus 1 up here, and then we come through and rewrite everything. Multiplying that negative 1 through, multiplying that 1 through gives you pretty much the divisor, and then change the signs. Bless you. All right, so what are we going to have when I'm finished up here? X cubes are going to go away. X squareds go away. Get 4x. What about this 1 and negative 1 here? Cancel out, so you just get 4x, right? And this is where we stop, right? Because the power here on x is smaller than the power here. Let's see. So we write up here plus our remainder, 4x, over our divisor, which is x cubed minus x squared minus x plus 1. So the integral, this integral can be converted, everything in here can be converted into this expression right here. So I'll go ahead and put that down on the bottom here. So this integral becomes the integral of 3 separate things. X plus 1 plus 4x over the divisor, which was x cubed minus x squared minus x plus 1 dx. All right, just let me know if you're okay. Click in yay or nay on this. Now what? Anyone? You can split them up, right? Because it's addition between these. So you'll be able to integrate these two. These two are pretty straightforward, right? So let me go ahead and do that. I'm going to have equals 1/2 x squared plus x. So I've actually taken the antiderivative of both of those terms. The other antiderivative, I don't know yet. So I'm going to just write the integral here because I haven't taken the antiderivative. I know that I would have gotten a plus c, right, when I did these two, but I'm just going to tack the c on at the very end of the problem. So now what we're presented with here is kind of its own problem now. This is its own thing that I've got to go figure out, right? Once I figure it out, I come back and just throw the answer in right here. So I'm going to go to the next page and do that problem. Well, we'll talk about what we're going to do on the next page. So the whole idea behind partial fractions was the first step is if the degree of the numerator is bigger than or equal to the bottom, you do the long division. Then whatever you get after that, right, what are you supposed to do? Let me see, come back up here. If the degree of numerator is less, move on. If not, you do the long division. For the remaining rational function, use partial fraction decomposition to rewrite the expression. So for the remaining rational function, this is it right here, I need to do partial fraction decomposition. Or something else. If it's something you can integrate with one of your other techniques, then go for it. But I don't see another technique that we could use here that would get this. So for partial fractions, what we're going to do is look at the integrand right here. I'm going to write it down. And I need to rewrite this so that it looks nicer than this. And the first step to doing that is to try and factor the denominator. You must try and factor this to make it something times something times something. So this is a cubic function, right? How can we try and factor this? I heard group it, right? Is that what I heard, group it? Okay, so on the side here, let me just write down what we're doing. We're taking this. Since it's 4 terms, the technique usually used for factoring 4 terms is to split the first 2 terms off and do a GCF, a greatest common factor, out of those 2. So what can I pull out of these 2? X squared. I'll be left with what there? X minus 1. Now for the second 2 terms, you need to pull something out so that when you pull something out, you get exactly X minus 1 left in parentheses here. So what? Negative 1. You have to pull a negative 1 out of both of those terms to make this factor here match up with this. And now, since X minus 1 appears in both of these, I can factor the X minus 1 out and be left with what? X minus 1 times X squared minus 1. That's the 2, I guess you could call them coefficients on these X minus 1 factors. And then finally, what's X squared minus 1? X plus 1, X minus 1. But I have 2 X minus 1s, don't I? So how about I write this way? X plus 1 times X minus 1 squared. All right, I'd like to make sure everyone just followed what I did right here, factoring by grouping. All right. So this is going to become, our expression there in red is going to become, was that red? Did it look that good last time? Or is it better now? The green you couldn't tell? Okay. All right, so the denominator becomes X plus 1, X minus 1 squared. All right, so once we've factored, we have to look at the factors and figure out what classification to put them in. And this is where all that crap that I put on that other page comes into play. So let me go back to our notes. It says, if the denominator has n distinct linear factors, distinct means they're different factors, right? For each one of them, I put A1 over that linear factor, A2 over the next linear factor, and so on and so forth. How many distinct linear factors do I have here? I have distinct linear factors. There are 2. I have X plus 1 as a factor. I have X minus 1 as a factor. Those are different factors. But the X minus 1 is squared. So let's go back to these notes. If you have some repeated linear factors. So you have a linear factor to a k power. Now, we did not have this last time, right? Then what you do is you rewrite, hold on, this should, I believe this right here is a typo. Didn't notice that before. That should be to the k. You might want to fix that on your notes. So if you have a repeated linear factor, then like we have what? X minus 1 squared? Yes? What you'll do is you'll put a letter over the linear factor to the first power, then another letter over that linear factor squared, then another letter over that linear factor cubed until you get to the highest power there of k. But for us in this problem, k is what? 2. Okay, so let me write this down and see if it makes sense. Let me actually work this out. Move this down here a little bit. So what I'm saying is that because the x plus 1, that is a distinct linear factor, I'm going to write a over x plus 1. Now, the other one is my other distinct linear factor, but it's squared. So I'm going to write a letter, b, over that distinct linear factor to the first power. In other words, it's this whole thing to the first power. I'm not going to write that, but that's what it is. And then I have to put another letter, c, over that x minus 1, but this time bring the power on that factor up. So it should be squared. And if this had been cubed, I would now do plus d over x minus 1 cubed. If this would have been to the fourth, I would have done a d and then an e. But I've exhausted the number of factors I have. I'm done. Okay, any questions? Now we get to play the game of trying to figure out what a, b, and c are. So what we did last time was we took this denominator and we multiplied both sides of the equation by that denominator. So when I multiply that yellow on the left side, they're going to cancel exactly, aren't they? Yes? And then I have to multiply, that yellow is going to go in here, and in here, next to the a, next to the b, next to the c. I think I'll write it down. X plus 1, x minus 1 squared, x plus 1, x minus 1 squared, x plus 1, x minus 1 squared. I'll even do it over here. X plus 1, x minus 1 squared. So we multiply both sides of the equation by the LCD. On the left side, we said it canceled, and what was left? 4x. On the right side, let's take a look. What cancels in this first term here? X plus 1s, and you're left with a times x minus 1 squared. What cancels in this one here? Just one of the factors of x minus 1. So this factor cancels. I'm going to change that squared up here to just the first power, right? So the squared becomes 1. So what's still here then? b times x plus 1 times x minus 1. Good. And then in the last one, the c term, the x minus 1 squareds cancel. And you're left with c times x plus 1. Okay. Quick vote. Now, last class, we talked about a short way and a long way. And I only showed you the short way because it worked, right? Let's see if the short way will work here. And if it doesn't, then I'll show you the long way. But I'm going to show you the long way no matter what, even if the short way does work here, because I think you need to see the long way. So let's try the short way. Anyone remember how we do it the short way? You get to let x be something to try and kill off everything except one of the letters you want. So let's try and get a, all right? To get a, I'm going to have to be able to what? Kill off the b and the c? So what can I plug in for x to kill off b and c at the same time? X is -1. right? -1 right here will make that 0. -1 right here will make that 0. It'll kill these two. -1 in here does not make it 0, so I'm okay with that. Do you see that that would work? So I'm going to be able to get A. Agreed? All right. Could you get B, though? I have to be able to kill off this one and this one. What's wrong with that? Yeah, look, to get B, I'd have to kill off A, which means I have to make X be what? 1. But that's going to kill off B. If I try and kill off C, I have to let X be -1, but that's going to kill off B also. Does that make sense to you? Now, you could go get A and then from that try and get B and C, and there are ways to get around it, but to me, the short way here is not the way to go. Does that make sense? Okay, so short, I'm going to just say here, fails, kinda, meaning that maybe you could work it out, figure out what A is, rewrite the whole problem, but with what? That's right. You could get A and C and then go back and get B. That's what I'm saying. There is a way to do it, but it's just, you know, what if you have another problem where you just cannot get one of the variables, that 2 or 3 of them will always be there, and that'll come up sometimes. So you just have to be prepared for another method. All right? So here's the long way. The long way, what you do is you just expand out everything on the right side. Multiply it all out. So let me do it. I have 4x on the left side. Now I'm going to do x minus 1 squared. What's x minus 1 squared? X squared minus 2x plus 1. Right? That's what you get if you square this. Then you would have to distribute a capital A through to every single one of those terms. So you would get A x squared minus 2a x minus what? Or not minus, plus a. So that is this right here. Okay, that's this. Any questions on how I got that? I'm doing it mentally. All right, what if we do this? Let's multiply the x plus 1 times the x minus 1. That would give us x squared minus 1, but then distribute a b through. So what would it be? Plus bx squared minus b. So that's x squared minus 1 with the b distributed through. And this last one, plus cx plus c. So there's where each piece came from. While I'm copying and pasting, you can let me know whether or not you got that or not. Let me stop and restart. Okay, so here's what we're going to do. At this point, we are going to collect like terms. So I'm going to look at things that have x squareds in them first. I'm going to write those down next to each other. A x squared plus b x squared. Then I'm going to look for things that have x's in them. Negative 2ax plus cx. And write those down next to each other. Minus 2ax plus cx. Then I'm going to look for things that don't have x's in them. A minus b plus c. I'm going to write those down next to each other. Plus a minus b plus c. Now what I'm going to do is on the ones that have x squared, I'm going to factor an x squared out. So tell me if you agree with this. Is this right here the same as x squared times a plus b? Yes? And isn't that the same as a plus b times x squared? Like that order doesn't matter. I can put the x squared out in front of the parentheses or behind. Okay, I'm going to put it behind and you'll see why in a second. By the way, the left side of this was 4x still. Now do the same thing, factor out an x from these two. So if I factor out an x from those two, I'm going to get, I'm pulling a positive x out, not a negative. So tell me if you agree with this. Is this the same? Is this the same as this? Yes? Okay. So I pulled an x out. And notice I put this in parentheses. You have to have that. And then the last one, there's nothing to pull out, right? So I'm just going to write it all here, but I'm going to put those in parentheses because it's not wrong to do so. If I put a plus in front of them, it's the same exact thing. Any questions? Now, on the left side of this equation, I hope you wrote in pencil, I want you to just add something in here. Do you agree with this? Is the left side of that equation 0x squared plus 4x plus 0? Yes? Okay, and the right side of the equation is a plus bx squared plus negative 2a plus cx plus a minus b plus c? Okay, so if this polynomial, if this quadratic on this side is supposed to match this quadratic, then their coefficients must match. That means the 0 here has to match this a plus b. The positive 4 here must match the this thing that would be in front of x here. And the 0 by itself needs to match all these together. If those match, then all is well. So this has to match this has to match this, and this has to match this. So let's write that down. I need a plus b to be equal to what? 0. So I'm going to write that down. A plus b must equal 0. The next thing I'm going to write down is negative 2a, watch the way I do this, plus c must be equal to what? 4. Not 4x, right? Just 4. And then what about a minus b plus c? What does that have to equal? 0. And what I've created here is a system of linear equations. This is a system, 3 equations and 3 unknowns. And so you can solve this various ways. And this is a pretty easy system to solve because right here I can get a relationship between a and b. And then I can come back here and get a relationship between b and a and c. And then I can come back in here and solve everything. Okay, let's take poll and make sure you're okay up to this point. You could also use matrices. But now let's talk about what you've got in your hand as far as the technology that you have. So how many of you have a graphing calculator with you? Yes? How many of you are using something other than a Texas Instruments? Anyone using something other than a TI? Anybody not have a graphing calculator? Just you? Okay. Do you have access to one? No? Okay. Get with me. I might have one in my office. What? You have one. Okay. So what I want to show you, everyone get your calculator out if you have it. I want to make sure you all know how to use your calculators to solve a system of equations. All right? On the test, you are allowed to use your calculator to solve a system of equations, as long as you know how to do it. Now, the way I'm going to show you to do this, I always get people to get all upset with me. If you know how to do this already on your calculator and solve that system, I'm not here to reteach that, all right? The way I'm going to show you is so that this way I'm showing you works on everyone's calculators. It doesn't matter if you've got the TI-84 or you've got the TI-89, TI-86, it doesn't matter. Everyone should have this functionality, all right? So what we're going to do is we are going to first translate this system of equations into a matrix, what we call an augmented matrix. So what we'll do is we will write just the numbers down. So remember, the A's are in the first column, the B's are in the second column, the C's are in the third column, and then the numbers are on the others, or in the last column. So write down the coefficients of A down the left side. You get 1, -2, 1. Coefficients of B, 1, 0, -1. Coefficients of C, 0, 1, 1, and then the numbers, 0, 4, 0. Okay, this is called an augmented matrix. Sometimes they put a line down like this to let you know it's an augmented matrix. If you have no idea, if you've never done matrices, that's okay. It's not, I'm just writing it down so you see it. Now, let's translate what this means, all right? Because this is important. A, B, C equals some number. Does everyone understand that this means that 1A plus 1B equals 0? That this means -2A plus 1C equals 4, and that this means that A minus B equals 0. Y'all see that from here? Okay, so what would happen if someone, don't write this down, what if someone gave you a matrix like this? What would this mean? A is 5, B is 2, and C is -3, right? So if we can get this side of the matrix, this first little 3x3 grid of numbers, this 3x3 grid of numbers, to not look like this, but to look like this, then wouldn't we have the answers? Yes? And the operation of going from this to this is called putting it in reduced row echelon form. That's the name for it. If you take linear algebra, that's what you'll do. You'll do it by hand. All right, but we're not going to do it by hand. We're going to do this on the calculator. So everyone needs to go into their menu where you can bring up, or in your catalog, there's an operation called RREF. Find that in your calculator, and I will come around and help you. It stands for reduced row echelon form. So yours is in your matrix menu. If you just go alpha, hit alpha first. No, back to your catalog. But you want to do it a quicker way. Watch, let me show you. Escape out of here. You're going to go to your math menu. Okay, go to your math menu. And then go to matrix. And it's number 4. And just hit enter and just wait. And I'll tell you what to do next. You find yours? Yours is in your, let me see this for a second. Did you find yours? Yes? Okay, just hang tight. Okay, you have a matrix menu right under the math menu. You have to hit the blue. Okay, so hit the blue matrix and then go to math. And then go down. It's down there. Next one. There you go. Now hit enter. Anyone need help at this table? Yes? Okay, so you have a matrix menu right there. See it in blue? You have to hit the blue first, and then go over to math, and then down, and it's like number 9 or the RREF, you pulled that up? That's right. I don't know if that's the right answer. You put the matrix in? Yes. Keep going. So you see RREF. Yep. Now hit enter and just wait. You all have it over here? Yes? You find it? No? Show you an easier way. Okay. See that blue matrix? Hit that. Okay. Then come over to math. And then go down until you see RREF. It's the second one there. Then hit enter. You good? Yes? Anybody need help? Everyone's good? What's up? Well, I found it a different way. But I heard you saying. Let me see. Okay, for you. Yeah, that's a little slow. Okay. If you want, you can go just to your home. Just go to your math menu, which is above the number 5. So hit blue. Okay. 5. Go down to matrix. Over to the right, and it's the third one there. Because with that catalog, where you scroll down, it can take a while to get to it. Okay, so everybody has pulled up the RREF, right? Now, again, let me say this one more time. If you know how to put a matrix in, it's not what I'm here to show you. I'm showing you how you can do this all in one step, all right? So after you've got this on your screen sitting there waiting for you, you're going to put a bracket and then another bracket. And I'll explain what these mean. The first bracket lets the computer know that you're about to start putting in a matrix. All right, so the first bracket, you're starting a matrix. The second bracket says, here comes the first row, okay? The first row. So this is start the matrix. This is first row. Here it comes. So what is our first row in our matrix? 1, 1, 0, 0. We want to put 1, comma, 1, comma, 0, comma, 0. So go ahead and put that in. 1, comma, 1, comma, 0, comma, 0. Make sure you find your comma. Then what do you think you put in? Bracket, close off the first row. That ends your first row. End row 1. Now what? Start your second row. So a bracket opened up. What's our second row? -2, comma, 0, comma, 1, comma, 4. Close. Reopen. Third row. -1, no, 1, -1, 1, 0. Then what? Close, close again, and then close parenthesis to close off the reduced row echelon form function. Enter. If it says syntax error, you put something in wrong. You have to make sure you're using your negative key, not your minus key, on those negative numbers. You have to close off the red one, yes, with the parenthesis, not a bracket. Anybody get it? Yes. You just insert it. You go RREF, and then you put in, like, you go matrix and then go select A. Okay, did you get it? What did it spit out? So again, this will depend on your calculator, how nice it is when it comes out. So let me see, yours, that's pretty nice. You should be able to decipher the answer as being 1, 0, 0 what? -1, 0, 1, 0, 1, 0, 0, 1, 2. Now look, I understand that you could have probably got this already by hand, solving that system by hand. I get it. But if that was a really complicated system, this would be faster. In fact, what if we had 5 equations and 5 unknowns? Right? 5 equations, 5 unknowns. A, B, C, D, and E. This would work. So this is preferred. This tells us A is -1, B is 1, and C is 2. We're not done. Yeah, we're not done. So where were we? We were here, right? We were trying to figure out what A, B, and C were. We just figured out what A, B, and C are. So I'm ready to rewrite this integral right here. Therefore, this integral is equal to a, which I said was -1, integral, a, which we said was -1 over, now this has to match up with what you had in the previous page. So what was a over? It was over the x plus 1. So you've got to make sure that's the right thing. X plus 1. Then it's plus b, which is 1, so over the x minus 1. And then plus our c, which was 2 over x minus 1 squared dx. All right. Now we get to integrate those. But do you remember last week when we said preliminary concepts, the stuff we needed to know walking in, and we started going over these? What if you have a constant over a linear? What if you have a constant over a linear? What if you have a constant over a repeated linear? Right? Remember this? I said we want to be quick with these because they're going to be the very end of our problem now. So that's where we are. So let's try these. This is equal to, what's the antiderivative of this right here, that -1 over x plus 1? So the -1 comes out, right? Natural log of x plus 1. Nothing else to worry about. What's the antiderivative of 1 over x minus 1? Natural log of x minus 1. What's the antiderivative of something that looks like 2 over u squared? So that looks a whole lot like 2u to the -2, doesn't it? The antiderivative of this would be -2u to the -1, so -2 over u. Do we have to account for that little a thing at all? Remember the number in front of x here? It's just a 1, so I don't care about it. So this should give me minus, what do you say, 2 over x minus 1. Then our plus c. But I've got to tack this onto the other answer also, right? Remember we had that stuff from before? Okay, so final answer. The integral of, where is it? Way back here. Here it is. This integral right here. Is equal to, we had one, was it 1/2 x squared plus x, and then this stuff in green, minus natural log x plus 1 plus natural log x minus 1 minus 2 over x minus 1 plus c. All right, there we go. I'll take a poll here to see if you understood that. That took us about, what? I want to say it took us about 30 to 40 minutes. Okay, let's move on. We only have 17 responses, but I'll keep going. All right, so the next one, integral 2x squared minus x plus 4 over x cubed plus 4x dx. All right, so when I'm looking at this, I exhaust all the other things that it could possibly be. I'm thinking polynomial over polynomial. This is looking like partial fraction decomposition. I need to look at the powers here, 2, 3, so no long division necessary, right? That means I need to go and try and factor the denominator. That's a great question. You could, but I think it would be more work. It works really well when your denominator is quadratic and your numerator is linear. But when your denominator is cubic and then your numerator is quadratic, you can still approach it that way. You wind up at the end still having to do the same kind of amount of work. Yeah. The reason why the quadratic one works so well is because when we did it, remember that eventually we got a number over a quadratic, and that went into our arctangent formula after we completed the square. This one won't work so well because the bottom won't be able to turn into the arctan. Does that make sense? Okay. All right. So factor the bottom. All you can do is factor out an x, right? And then you're left with x squared plus 4. And that's it. I'm doing this in red because I'm no longer doing the integral. I'm working on partial fractions right now, or the decomposition of this. So let's go and refer to our notes now. What do we do when we have, let's see, a distinct linear factor, right? Do we have a distinct linear factor in there? A distinct linear factor? X? That's a distinct linear factor. This other one is quadratic, isn't it? And it cannot be factored. X squared plus 4 can't be factored. So this is what we would refer to as a what? Let's see. Repeated linear? No, we don't have that. An irreducible quadratic factor. So what do we do when we have a quadratic in the denominator that you cannot break down? What you will write is, you will rewrite that quadratic, okay? But instead of putting a number over the quadratic, you put what? A linear expression that you don't know over a quadratic. Why? Why would you put a linear expression over a quadratic? Because we did those, didn't we? I mean, didn't we do those where we had a linear over quadratic, and that's where we massaged it and made it look? So if we can get it to that point, we can do it. So let's try it. So I'm going to rewrite this as first a letter over x plus now a linear expression, bx plus c, over the irreducible quadratic. You know what to do now? Clear your fractions out, right? Multiply both sides by the LCD. What would you have on the left side? Left side. 2x squared minus x plus 4. Okay, now on the right side, when you multiply through, you get a times the x would have canceled, so you got a times x squared plus 4. And then you would have had plus, now be careful here. It's the bx plus c times x. So how about bx plus c times x? Do I need to write the LCD in here again in here? How about if I just do the yellow? Is that good enough? Or yes, you know what to put in there and then you get things to cancel? Sure. You all right? Okay. Now, there's no way you can ever kill A off. Do y'all see that? Because what would you have to do to kill off A? You'd have to make this 0. And unless you're allowed to use imaginary numbers, you can't make that happen. So I'm just going to go to the long way. All right, I'm going to go long route. And so I'm going to just expand it out. I'm going to rewrite the left side. The right side is ax squared plus 4a plus bx squared plus cx. So I distributed the x through here, distributed the a through here. Let's collect like terms. What do we have? Ax squared plus bx squared, I'll write that as a plus b x squared. How about my c? Just cx, and then anything by itself without x's, plus 4a. And now we get to match things up. The coefficient of x squared must match with a plus b. The coefficient of x, which is -1, must match up with c. And then the number by itself, plus 4, must match up with 4a. I'm going to write down the three equations, even though some of these are already solved, right? Let me just write them down. First equation would be a plus b is what? 2. The next equation, c is -1. The last equation, 4a is 4. I have a system of linear equations, 3 equations, 3 unknowns. But this one is not worth going to the calculator for. Y'all see that? You already know what c is, right? Here for a, if 4a must equal 4, then a must be 1. So just by looking at this, I know right now c is -1. I also know by looking at it that a is 1. And if I know a is 1, then I can come up to this equation right here, and I can put 1 plus b equals 2, which means that what? b is 1. So I know what a, b, and c are without having to use my calculator. We'll take a poll, make sure you're all okay. This one's going a little quicker, isn't it? And now at this point, I need to rewrite the integral. Remembering that I'm going to be rewriting it using, where is it? This right here, right? What we found for a, then bx plus c over this. So the original integral is equal to integral a 1 over x plus bx plus c. So it's 1x minus 1. So just x minus 1 over x squared plus 4 dx. Can you integrate 1 over x? Yes, that's natural log x. This one is a linear over a quadratic. That is a linear over an irreducible quadratic. That's what we've done. We've done something like that before, so we shouldn't be too afraid of it. But does anyone see how we can do this one really, really easy? That would be too hard. If you let u equal the bottom, then you get what? The derivative of the bottom is what? 2x, you're off, but you can make it right. But then the minus 1 kind of throws a little bit of an issue into that. You see that? So, well, what about this? Hold on. I'm going to make this as easy as possible. Did I hear split? Can I just make that a minus 1 over x squared plus 4? Isn't that the same? If I split this top up, put the x over this, and then put the -1 over this, I would have these two things, wouldn't I? The antiderivative of this that's, what is it? No. Arctan. Arctan. That's 1 over a squared plus u squared. This one here, this is the one we could use the basic substitution. U is the entire bottom. The derivative of that is 2x. We're off by a factor of 2. That's what that one would be. Then this one would be arctan, and this one would just be natural log. So I'm just going to write the answers for these down, because these we should all be able to get to these. Given a little bit more time, you should be able to get each of those. So we'll have natural log x plus, 1/2 natural log x squared plus 4. And then the last one would be minus, see if someone can apply the formula to this one. What's a here? 2. The formula says 1 over a arctan of u, which for us is what? X over a plus c. I'm a little concerned that I lost quite a few of you here. If you actually did this one on the side, you would make a substitution. U is equal to the bottom. The derivative of that would be 2x dx. You have an x dx, you don't have a 2x dx, so you would come in here and go 1/2 du equals x dx. You'd rewrite the integral. The x dx would be the 1/2 du, the 1/2 would come out. It'd be 1 over the bottom, which is u du. The antiderivative of this is natural log of u, but then there's a 1/2. That okay? So that one is just a basic substitution. This one's just a formula. This one is just a formula 17. That's formula 17. Okay. It's 213. We have one more, so let's see if we can get through this last one. So fair warning, you know, the problems I gave you, the take-home ones, the group ones, you know, you're not going to be able to just go back to the notes and be like, oh, he did one exactly like that. I'll just copy what he did. It's going to require you to think through the problem. So they all have a little something special to offer. I mean, that in theory, right? In theory, that's the way I feel, but I don't know. I mean, everyone is so different in a class like this. You can do all the homework, you can do all that and be good with it, and then you come to the test and you know you get anxiety. I mean, everyone is so different that it's hard to say. But if you can't do them, you're probably in trouble. All right. First step. Long division. Okay. So going to multiply by what? 1. That'll give me my 4x squared minus 4x plus 3. And then we come through, change the signs. Add straight down. X minus 1. That's my remainder. This one actually doesn't look that bad. Doesn't look that bad because of why? We just got what? What did we just end up with on that remainder? A what? A linear over a quadratic. And I want you to start to feel comfortable seeing linear over quadratic as something we can tackle. So you have some options here. I mean, we can try and take this to partial fractions right now. We could do that. Now, last class, what did we do when we had this? We let u be the bottom, and then we tried to massage everything to make it look correct, right? We could do that, but those took a while, didn't they? Let's see if it's possible to factor this. Let's see. Can you factor that? Does it or not? I'm waiting for an affirmative or not here. Can you factor this? Okay, let's take a vote. Can you factor that, yes or no? Yes. All right. So how do you think? Can you factor it over nice numbers? Is what I should have said. Like, okay. It's not factorable over real numbers anyway. So there's no way we can use partial fractions here. Not, well, I should say we can't split it into linear factors. So what we have on the bottom is an irreducible quadratic factor, isn't it? And doesn't the method say that for irreducible quadratic factors, that I'm supposed to try and get it to turn into a linear thing on top? Yes? Isn't that already what I have? Yes. So partial fraction is completely dead in this problem. The only thing it was useful for was the long division part. Now what I'm going to have to do is play the game we did last time where I try and match the, take U to be the bottom and then try and match up the top with that du massaging thing, all right? But let me kill off this first integral, that other one. Antiderivative of 1, x. So this is going to be equal to x plus this integral. I think I'll take this to the next page with me and work it on out. All right, so I'm going to let u be what? The whole thing, right? 4x squared minus 4x plus 3. The derivative of this will be 8x minus 4 dx. And do I have an 8x minus 4 up here? No, but I can make it an 8x minus 4 by first making it an 8x, right? So I multiplied on the outside top and bottom by what? 8? We didn't do this one, did we? Not exactly. Similar, right? Not exactly, though. What did we do? This looks awfully familiar. We did this one exactly? No. Right here? This is the same exact problem, isn't it? Hey, I did it that way so we wouldn't have to redo the work. I just forgot that I did it that way. But it looks so familiar. So go back and let's look at the notes from last time. Day 7. Where is that one? Did we do it? Did I pass it up? This one right here? There it is. So this was it. I did that already. So go back and look at this. All right. We went through that. Then we had to, after we split it up and made it look the way we wanted to, one of them peeled off and it was just a nice natural log. The other one, we had to complete the square on it, blah, 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 blah. And then we put it all together to a final answer. So the only difference between that problem and the one that I'm doing right now is what? You have that other part in front, that x in front from the long division. It's the only difference, okay? So I'm just going to say C, day 7. Notes. What's that? Group? Is that? Yes. So at this point, I think we're going to say we're done with partial fractions. Your homework, I had told you to stop, right, at a certain point. Yeah. Now you're free to get through the rest of this. Where did I tell you stop? 17. So you should be able to do off page 334 the rest of those odds. So the final assignment would be like 7 through 33 odds. It's a lot of work right there. All right, so we have about 20 minutes. You're free to work together. Remember what's due next time, right? All right. I don't want anyone taking off. I want you working, all right?